Yo! Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. This is Bug Squashing Part 13. We're still working on this. Sorry about the mic. I don't know what the issue there is. OBS seems to not want to use my sound card lately. And I have to go in and change all the settings for all my inputs. Don't know why that is, but whatever. Appears to work fine after I set it manually. Before we begin, I would kind of like to share something kind of clever and silly that I just did. Yeah, welcome to another episode of Ferris Talks with the Mic Off. That's exactly what this is. This happens way too often for this to not be a thing now. Usually the problem is that I have my mic unplugged and my cable that goes from my TV to my sound card plugged in so that I can... Oh, Rytone says, sounds like the wrong mic, worse than usual. I'm going to doubt that. Oh, you know what? You're totally right. Thanks for the heads up. All right, that should fix the, fix the quality as well. Jeez. One sec. I'm just going to check my settings here. Oh, I'm such a pro. Before we begin, I just want to share something funny that I did with MSX stuff, because I did this like right before the stream, and I just thought it was really clever and the kind of thing you guys might appreciate. A couple streams ago, I started playing with some MSX stuff. Really, really basic. All I did was just get some super basic code running that I don't remember even what it did at that time. I think it just printed. Currently, what it does is it just changes the background color as fast as it can, so it gets sort of this kind of classic screen. But after that stream, I kind of, like, what I was stuck on was particularly how the memory mapping works. Now, I wrapped my head around a lot of that, actually, and also the slots and banks in WLA. I'm going to skip over a lot of those details, but there's something kind of clever that I did that I just am giggling about. So basically, one of the things about MSX is that you have these four sort of pages of memory that are 16 kilobytes large, and those make up your full 64K of memory that your CPU can see at any given moment. Now, there's a couple registers that basically select what is visible in those different parts of memory. And the thing is that you have, and those are called slots, so per page you can select which slot is actually visible within that page. And the problem is that even though MSX2 machines are guaranteed to have at least 64K of memory available, it's not guaranteed which slots the RAM actually is. So you normally have to do like some kind of search or rely on them being in a certain place, and that'll lead to a bunch of game incompatibility and stuff. What I've noticed a lot of demos doing, actually, now that I've looked at some disks, is they actually distribute the demos as MSX-DOS disks, with an autoexec.bat that will start their demo as a MSX-DOS program. Now, the interesting thing about that is that the MSX-DOS environment requires 64K of memory to be visible for the entire range. So the convenient thing about that is that, first of all, you don't have to worry about finding the memory at all, because it'll be visible by the time your program starts. The other interesting thing is that then you get to use the MSX-DOS routines. Now, the latter part is not that useful, I think. I don't know if it's really that useful yet, because, I mean, most of what you'd be doing is like loading data files from the disk. And you can do that without MSX-DOS, because the MSX machines with disk drives in them contain ROMs that would enable you to actually read and write from the disk. However, that RAM thing is pretty useful. But there's some issues with this, because MSX-DOS appears to still be copyrighted. MSX-DOS 2 does not, but MSX-DOS 2 requires 128K to run, and my particular machine doesn't have that. So I was kind of looking at ways to get around this, either to do my own RAM search or what I ended up doing, which is actually super cute. So what I realized is I started looking into how the boot process of the MSX actually works. And it's a bit unclear to me. There's a couple ROMs that execution bounces between. Like, it starts up in sort of the main BIOS ROM, and then if there's a disk present, execution actually appears to transfer there, and then that will try and like load the boot sector from the disk, make sure that that's okay, and then it will actually try to boot MSX-DOS. Now, the way it does this is it actually loads msx-dos.sys, So there's basically two files that make up MSX-DOS. MSX-DOS.sys, which is basically the DOS itself, and command.com, which is your command prompt that'll run other commands as well. Now, the interesting thing is that the boot process will actually set up the full visible 64K of memory before it loads the MSX-DOS.sys. And then MSX-DOS.sys will like relocate itself and load command, and then you're in DOS. But what I realized is there's no like checksums or anything for the MSX-DOS.sys file because there's multiple versions of DOS. So you would have to have like a checksum algorithm that would be agreed upon there. It doesn't appear to be one of those. And I also realized that, okay, since it's not MSX-DOS that's actually preparing the memory environment, if we could get the bootloader to load our demo instead of MSX-DOS, we would actually already have the environment that we expect, minus, of course, DOS itself. But if that's not like that necessary, then that's actually fine. So what I did is I adjusted all my stuff so that this is just a program that starts at 100 hex, which is the same entry point that MSX-DOS.sys gets. And all I did was I just generated, let's see if I can show you this. I generated a disk file with the default bootloader and everything, or the default boot sector. And I just called the demo MSX-DOS.sys. And it appears that it loads it just fine, which is awesome. So let me pull this up here. I just have to share this because I thought this was so funny. Yeah, so I mean, all it is just one disk with this MSX-DOS.sys file on it. But it appears to load the demo just fine if I do that. So I can do my make test here. And instead of booting into the command prompt, it just boots OK with full 64K visible into my own demo. So then I don't need an autoexec.bat. I don't need to do a separate file, and I don't need to distribute MSX-DOS. So I'm actually pretty happy with this. I need to test it on some more machines and do some other things with the environment. Particularly, I want to see, learn a little bit more about how the disk ROM is mapped into memory, because that may present some issues with the maximum size of the file that we load initially, or where things have to be in memory. But that's fine, because we could do like a multi-stage loader, stuff like that. So yeah, there's a couple more things to look into there, but that was actually pretty funny and totally gets around the licensing issues while also solving the technical problems. And it means we have more space on the disk for our actual demo. So that's actually pretty cool. If you guys are curious about that more, here's the actual commit that I did that in. I'm doing all the MSX stuff just open source, so feel free to play around with that. Although I haven't documented how to set up like the environment and everything. I'm actually running with the emulator with my own dumped ROMs from my own machine and everything, and so I think I can't distribute those, but I could at least write kind of a guide to how to set that stuff up on your local machine, because I need to do that for the other people that want to make a demo with me anyway. But yeah, so I'm pretty happy with that. I just had to share that because I did that right before the stream. Just thought that was cute. Anyway, the actual stuff I wanted to do today. We left off last week by, unfortunately, just sort of rediscovering that Ben Naffin was wrong in the ways that I knew it was wrong already, which is a little bit disappointing. But it made me kind of rethink how we're going about solving this problem. And particularly, it seems that the timing in a given frame for when different events with the video hardware in particular are happening may be the culprit. At least the divergence we saw in the code paths between our emulator that was not working correctly and Naffin that was working correctly, albeit it was working correctly because of two bugs that kind of complement each other. So correctly asterisk. It really seems like this one branch that looks at the state of the video hardware, or looks at particularly which video hardware interrupt fires at a given point, is going to be our culprit. So what I want to do is I want to build a timing diagram of particularly this one register that will give us the status of different interrupts that have fired. So basically what I want to do is, if you can imagine, this is our Virtual Boy screen. Of course, this is assuming like one 2D screen. I basically want to have a diagram that's going to be kind of like this. How can I do it up bar? I can do this, I guess. Whoops. 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 What just happened? Oh, F12 does that apparently. Okay. Anyway, I'm thinking something like this for different bits of the hardware state here. Something along those lines, literally. So what I want to do is basically set up the hardware so that it's going to so we have a concept of display frames and game frames. You can set it up so that there's a game frame every 2 display frames, and what I want to do is have it draw everything and display everything normally within that first of the game frames, and then I want to use the second frame to actually sort of rasterize this, or I'll probably just render it with characters for a bunch of different lines on the screen. Just some super basic stuff. And I'm hoping that that'll give us some pretty interesting information with which we can go off of. Now this may take a little while to actually produce this program, because we need to produce this program entirely on the system itself. Excuse me. So I'm not sure how long it'll take, but I thought that would be a good thing to do, because then we can actually run this on the real hardware at least look at like how is the timing supposed to look for a bunch of different registers, or at least a bunch, like, I think this will only show a bunch of bits for a given register, the way that I want to implement this. And then we can rebuild it with watching different registers and stuff, as long as it basically works. So I think that's how I want to go about this, and I think it'll be kind of fun. Mad Moose, that sounds awesome. I don't know what's in my throat. Hold on. I'm actually going to go cough something up. Sorry about that. Hopefully that's fixed enough. So what I did at the end of last episode is I kind of just like forked this super basic project and just got to the point where it basically does nothing. So that's what we're going to start with. I think here we need display enabled. We need drawing enabled. This, I was doing an interrupt previously, but right now we don't want to do that. I'm going to keep this stuff around, though, just in case we want to use that. I'm just going to, copy a bunch of this stuff. This we don't care about. In fact, I would actually have written that this way. Don't need interrupts for now. And here we can, set background color. This should get us just a pure white screen or red screen or pink screen it'll be in this emulator. Yeah, there we go. So this just sets the hardware to, first of all, display whatever's in the frame buffers every frame. And I also set this up already, so it's going to be every other frame it's going to draw, but it's going to display every frame. And there's also this wait here, which is some code I found in some other things. So this, I'm guessing, is just, probably wait for v blank before it starts banging on hardware registers. By the way, hi to guys in the chat. Skeleton, Garrett Kelly, Dark Second, Jacob Mishka, Daniel Collin, Rytone, Mortaray. Hey, how's it going? Tom Go, Baggers, Zamak. Did I say Dark Second already? Probably did. Jacob Mishka, Mad Moose, Love Like Semtex. How's it going, guys? But yeah. So I think this will actually be pretty easy to set up. I also pulled up this other demo thing, and it basically is just going to turn the display on, which is basically what we're doing here. I kind of wanted to do this by hand when we set up a hardware test earlier so I could simplify it, but I want to keep it like this as well, because especially since we're going to be timing these, or like looking at the timing of the hardware, I want the hardware to be in a very deterministic state. So I would really like to have this all be very explicit. Nice skeleton. So yeah, one of the things we have to do here is we have to set up the worlds. Now the worlds are a bunch of different kind of layers that the hardware is able to draw. And basically there's this table of 32 different worlds, and the hardware will go from the 31st, assuming zero indexing, the 31st world, and then count down. And as soon as it has this one bit set that determines the world as an end, then it will stop. So we want to definitely set them up kind of this way. And so we want to do, I think this is doing left on and right on for which of the two displays it'll actually write to. I'm not really sure what this OVR thing is. But I think what we want to do here is, I'm just going to copy this here. And this one we're going to do left on. We're going to do right on. So we're going to do both of these. And then we're going to set the next world to off. And this should give us, well, some crap is what I expect, or nothing, because it'll probably just still draw the background with nothing on it. Don't enable world end, the end is not, exactly. The other thing I want to do here, this loads a bunch of, it does this copy mem routine that copies a couple of these, what is it, charsec 0, bgmap 0. I don't know what, oh yeah, these are probably the characters for the adjustment screen and the background for the adjustment screen. This demo in particular, I can just run this. I'll show you what this is. It's just a demo that displays this kind of Planet Virtual Boy config screen. And the point of this screen is it's, or calibration screen, the point of this is it's supposed to show at the beginning of every game, where you have this image that's really similar to itself, and you have a left version and a right version that's slightly different. And so you would, because it has these things on the corners, these logos in the corners, and also the middle part is sort of very clear, you're supposed to use this to kind of calibrate the optical settings of the device right when the program starts. But the nice thing about this is that this is just a really simple demo that all it does is load the characters and the background map into memory. And that's it. And then just show that. So that's why it's using two worlds to display this as well. One for the left and then one for the right. Now this MY thing, I'm not sure what that is at all. I don't remember what some of these attributes are, to be honest. Although, I totally have emulator code that I can read and find out again. This one. So particularly might be draw current block. Yeah, because here's the window entries. Now, of course, I named these kind of written out names, so I don't really know what the MY was meant to be. But anyway, probably doesn't matter because I think we're going to have the right settings with just this. However, we are going to need to put some data in the character and background things here. I think for now what I'm going to do is just set up a super basic like crap tile map where I'm just going to hard code a couple different versions of tiles and then start by displaying those, because this is actually the first Virtual Boy program I've written that actually displays any graphics. I want to kind of stay away from other character generators and stuff if possible and just do it by hand, although I might rely on some of that stuff for the map data, but we'll see. I need to look up the resolution here again. No, it was 384 by 224, right? That's actually here. Yeah, so I don't need to look that up. And then the tiles are 8 by 8, and if I recall correctly, the tiles are such that it's 2 bytes per row of a character. So you have like a character is an 8 by 8 pixel block. Each pixel is 2 bits per pixel, and so there's 1 byte that is the low bits of the like. So it's 16 bytes per 8 by 8 character. The first 2 bytes are the top row of pixels, and it does the low bits and then the high bits as separate bytes, if I recall correctly. Now, for this use case, I think we really only need like 2 colors, so I'm just going to make those the same things. But I did want to look at this, yeah, the character segment 0 and the background map 0. So this is going to be the map that is the indices for all the tiles, and I believe those are actually 16-bit each, which is probably what this times 16 is doing here. And then, yeah, this is going to be 256 characters by 16 bytes, and this is going to be 450, which I'm guessing if we take 384 by 224 and we divide it by 8 and divide it by 8, we'll get a number that I didn't quite expect for that, to be honest. Let me do that again. 384 by 224 divided by 64. Okay, so I did do that correctly. Wondering why this is 450. What if I divide this by 2? Is that what we get? No. I'm not actually sure why they're using 450 here. But I don't think that'll make much of a difference to us. Oh, wait a minute. I think I do remember now, because it's not, there's like way more in the map data that you need to specify than just the top, or just the screen width, I believe, because you need the full width of the like, there's a world, and then the world will display a segment, and you need the full width of the segment, I believe. Something like that. And that's probably why this is character segment 0. So that's probably where that number is coming from. Anyway. Yeah. So a couple mapping things that I'll have to kind of remember as we go. But I think the first thing I want to do is, if we get BG map 0 here, or sorry, char seg 0, this should, I'm also going to, I'll just search for this, by the way. Here. Yeah, this is actually where our character segment is. Nice. And this is just the value itself. Okay. Cool. So if we just, I'm probably going to copy this. And we're going to make our own little tile map here, which is going to be fairly easy, I think. So I'll call this the character data and the character map, which may be a bit confusing, but whatever. So we're going to do the same thing here. We'll do 2 by 16 for now. Just to kind of hard code this because it doesn't really matter. And then this will be our chart data. And so here, just going to write this out. I just want to look at what the syntax was for this. This was in here, demo 1, and we can do the, okay, so just const byte here. Do the same thing like that, and we'll do our char data. Yep. Cool. So, I'm actually not going to make char 0 empty at first because I want this to display something just to make sure that we're getting this right. So I'm going to do 5 5 over and over again. And the reason I'm picking 5 5 is because that's going to be an alternating bit pattern. And if we do like AA, that'll be the other bits. So like every other bit set, which is, I think, a pretty good thing to start with here. So we should basically see like vertical lines down the screen. And we didn't. We just saw a darker thing, which means I'm probably wrong about how the tile data was set up. Actually. Draw a char pixel down in here. Finally, we get to the unpacking. The emulator tries to reuse a lot of this code, which is actually pretty nice altogether. But yeah. So the char offset is the offset of the character plus our Y position times 2. So I was correct at least that it's going to be 2 bytes per row in the character. The data is, I actually just read that as a half word. Okay, so this is actually, I was totally wrong about this, and this actually totally makes sense that we're seeing a dark thing now. Instead of the low bits in one byte and then the high bits in the next byte, I think I'm thinking about that because I think that's what it is on C64. This is actually just the 16 bytes themselves are like every 2 bits in the 16 byte value is going to be interpreted as 1 pixel. In that case, then we want to do something else. So instead of 5 5, which gives us an alternating bit pattern, except in fact I'll even show you this here. We go into hex and do 5 5, so you can see this is 0 1 0 1 0 1 0 1. We want something like 1 1 0 0 1 1 0 0, for example. That's going to be CC. So we'll do CC that many times. Actually, we want this. And that should give us vertical lines. It did not. I'm a bit surprised about that, to be honest. Wonder why that is. Because this literally just reads a 16-byte value, and then it will shift it by the X position times 2. So that's 2 bits for every X position, and then adds it with 03. So that's our 2 bits there. And then it looks this up in the palette. It could be that we've set the... Okay, no, the palettes look okay. Oh yeah, our background color is totally 3. So let's set that to... Whoops, do that again. Let's set that to 0 again, and that'll mean it's black. I keep switching these, but yeah. Yeah, Dark Second, you got it. So there we go. There's our alternating lines pattern that I expected. So now we at least know how to arrange the data. I'm not going to waste time doing like a little converter for this. I'm just going to hard code a couple characters, I think, because it'll just be easy enough to do that. Let's just do this. Empty and solid to start off with. And then what I'm going to do... So I'm just kind of dipping my feet here to get a feel for how we're going to write the graphics here, and then we'll figure out based on what I feel like is going to be easy how we're actually going to draw this stuff. So this did not build. Oh, what happened here? Let's just file a directory. I actually think I know what that is, and it's a really, really crappy thing with this VBDE thing. So I have this in another folder here. I think this is the same problem we saw when I was doing those initial hardware tests, where it seems like something gets weird with the paths. And hold on. And of course, the time I stream with my window open, there's crying children outside my window. But I just want to deal with it because it's been hot out today. I think we end up with this just like super deep recursive folder structure. And we got to clear out the build folder every so often. Yep, that fixed it. So I'm guessing that's what that was. Kind of annoying that it does that, but whatever. Should be fine here. However, yeah, this is not actually empty now. That's what that is. Members, I can't hear them over the shouting children outside my window. Nice, that's all black again. So it looks like our map is basically already set to be all zeros. Now I don't want to rely on that being the case from the hardware. We may want to, in particular, clear all this ourselves. Probably will want to do that, in fact, but we'll see if we get like weird glitchy graphics. In fact, actually, what I kind of should do here, while we've got this stuff set up, I actually should do a hardware test with just this to see, fire this up on the hardware a few times just to see if we end up with, yeah, how much of this we can rely on. I'm guessing we'll still want to clear it, but if I can not write the code, I'm gonna be happy. Let's just set that up really quick. I think even this has can fire up the Flash Boy for me, which is kind of cute. So we should get the in here build output pad, which is nice. And I should be able to flash that to the device and then grab my Virtual Boy. It takes a minute. But it'll get there. I'm totally dressed for the occasion again with my red and black and the Virtual Boy. It's going to be better to do little tests like this often when building this ROM. Then figure out that, oh, something's wrong at the end and we don't know what it is. Especially when you're new to coding a piece of hardware. That really helps. I should get one of those Virtual Boy t-shirts. I should get several of them. Need more Virtual Boy swag for sure. Yeah, this takes a minute. Yeah, I forgot I totally was wearing this shirt on Sunday too. I did laundry yesterday. So yes, I totally do, but yeah. No, I didn't. I didn't duct tape webcam or webcams to my Virtual Boy yet, so. Of course, we've got Mario Tennis in the Virtual Boy. We'll be looking at that more soon. I gotta be careful when I take the games out of this thing. Already kind of scuffing the labels. It's a bit sad when they're in that good condition. I'm getting all black. Which is not great. Just to be sure, I'm going to put Mario back in there and make sure I didn't... Oh, whoops. Guess what I forgot to put back in the Virtual Boy? That would explain it. Okay. So what I get, it's probably going to be too hard to show. But basically getting mostly the vertical lines, but also a bunch of glitch lines. And that actually makes perfect sense because I don't think we've explicitly written any of the map data. We're just kind of expecting it to be a certain way. So I'm going to write a routine that clears that first, and then we'll test that again. I'd be a bit faster about this if I had written some actual Virtual Boy software before, but I don't really mind taking my time and doing this right. Yeah, so here we set up the char data. For the map data, I think we want to do a little loop to clear this. So if this is BG map 0, where is that here? Oops. Is it just BG map without underscore? Yeah, it was. That's right here. BG map base plus 2K hex. Now, if I recall correctly, if we dig in here, this is drop char pixel, char entry pixel. So this is given a entry in the map and like pixel X and that stuff, it'll draw that. Draw segment pixel. Given our segment stuff, we'll figure out which character entry to read from the segment. So looking at this, just multiplying by this 64 here, I think our segments are 64 tiles wide. And I'm seeing some 512 stuff here, and that totally sounds correct to me, if I recall correctly. So I think that's what this is. Yeah, because this even does divided by 8, which is the tile size, and then segment chart. Yeah, so our segments must be 64 by 64, and that sounds right if my memory serves me correctly. I could just look at the docs, but it's kind of nice to refresh my memory from the code that I wrote instead. I kind of prefer that if possible. And then maybe this 450 starts making more sense. If we do something like 450 divided by 64, whoops. We're going to get 7. That's a bit odd. Yeah. Not entirely sure where that's coming from, actually. I actually want to look at this. This actually writes quite a lot here. But yeah, what we can do to start off with, for example, is since I know that this was like assuming that a segment is 64 by 64, I can just clear it that way. So let's go ahead and do that. We'll do it like this. We'll do gmap data. Yeah, bgmap 0. I think this just gives us, yeah, this plus, okay. So we'll do something like this. Could totally do like a mem set here, but I want to play with this a little bit after, so we'll do this. We'll do also make a byte pointer. Map pointer is going to be this. And that way we can do like that, and then we can do map pointer plus plus, except we actually want to do two of these, don't we? Now I'm fairly certain given the character entry, we have the palette as some of the bits, whether or not it's vertically or horizontally flipped, and then the index itself of the character, which is quite a large range, actually. And so just setting all those bits to 0 should be all we need to do, which is what this is going to do. So it's going to set this 64 by 64, which, just to do the math here, is, yeah, 4K, 1K hex. Sounds about right. Let's try that. In this case, it should look the same in Manafin. And of course, we have C99. Good. So we need to do this. Hey, Dax Pelicus. Yeah, so we should get the same thing here. Just to test, I want to see if we can get all solid by, so the char index is the lower bits, which is actually quite nice, because then I can just do this, assuming this is Little Indian, which I believe it is, and then we should get solid here. So I'm going to go ahead and test this line thing on the hardware. Yeah, C99 is not my favorite, but it'll do for now. Go ahead and flash this again. And trust me, even though this takes a while, this is totally the better way to do it than just make everything and then find out it doesn't work on the hardware for some stupid reason that we missed. And then have to run it a bunch of times anyway to isolate what the problem is. Even though I'm skipping a bunch of stuff by just like clearing the map, I think there's a bunch of other registers that we should be setting to 0 just to be sure. But we'll see. A good way to detect that is just to run this a few times every time I run it. Just boot the machine a few times and see if it's different. Oh yeah, this is career newing hard. Steampunk Saints, thanks for the follow. By the way, hi, local hoster. Yeah, exactly, baggers. I actually don't think the program itself will be that hard to write. But it'll take me longer than usual to think through it, just because I have to think about a little bit extra about how we're going to write it, because I haven't done this before. But I don't think it'll be too bad. We do have floating point, which will help us do a bunch of normalizing stuff. And I'm thinking I'll quantize the graphs to character positions, because I think that'll give us enough, a rough enough, like a precise enough graph. Maybe it won't, but we'll see. But that's what I'm thinking. Okay, let's try this. Good. So now we get what I expect. So I'm just going to run this a couple more times. Apollo Team X, this is C. We're writing a program for Virtual Boy at the moment. Oh, it looks like I actually have a scan line going bad in this machine. But I need to open it up and look at that stuff anyway. Yeah, just going to run it a couple more times. but it looks the same as it does on in the test, which is really good. Cool. So the one thing that I'm going to do now is just to make sure that I'm sort of interpreting this correctly. I want to do a couple more test patterns here. Particularly, I want to do something like this. We can do, I think it's at the beginning of the scope you can make variables. Isn't that what it is in this C99 it was? In which case, I'm actually going to try this here, see if that builds. Been a long time since I wrote this kind of C. Yeah, because we can get away with it here. It's actually kind of strange, but yeah. Does that work? Appears to. Okay, nice. I want to do this. We'll do X. Something like that. Again, we're ignoring a lot of the bits here, but that shouldn't matter. So here we should get like a checkerboard pattern, just like this, which is great. So I want to test this on the hardware as well, just to be sure. Oh, sorry, I think this is C89. I don't think we have the C99 flag enabled. That's why I ran into that issue. So I'm gonna go ahead and flash that. Running a couple different emulators while we're sitting here waiting. This should also work in our own emulator. Fire that up. Oh, gotta build because I'm using a different Rust right now for demo stuff, but I think it should still build. We got time. No, we got errors. Then we'll do this. Oh, love Rust Up. Hey, the Swiss. Drunken Soul, thanks for the follow. This program should run in the emulators. Very basic. Just test it in a couple other emulators. Now testing it in Rust Boy. And perfect. Looks exactly right. Which is great. So yeah, so seeing exactly the same kind of basic pattern in the emulator, which I'm very happy about. So what I think I want to do is set up kind of a character set here. Just a really basic one. That will be, how do I want to do this? Yeah, we'll set up this empty character set here. And since this is going to be like a timing diagram, I think I want, to do this in kind of a simple way. In fact, what we can do is we can have We can have a character where it's just all flat on the bottom. And then, by the way, 224 divided by 8 gives us 28 character rows high, which is really nice. We can fit a 16-bit register in here quite easily. Why is this? Oh yeah, it's white in Rust Boy because of the way that I mix the colors. So this is actually perfect in Rust Boy as well, which is great. Yeah, I think I want an empty character, and then we want a solid character. Actually, we don't need a solid character, but let's do a. I want to do like a line that's down at the bottom, and then I want to do kind of a. We'll do a line that's at the bottom, and then we'll do a filled character for the one that's at the top, and that way we don't have to worry about like doing the transition lines and stuff and different character combinations that'll give us like a different vertical lines with the horizontal stuff. So for zero a 0-bit, we'll just have a line at the bottom, and then for 1, we'll have something that's filled in. I think that'll be easy. So then we have an excuse to have the solid char, and then we'll do bottom line here. It's going to be our char 2. For that, I mean, it's basically everything except the bottom pixels should be FFs, I think, is all that is, which is quite nice. Oops. I think that should be that. And so to test this, I'm just going to make this 2 here. So we should have all that. And in fact, I can... No, I think this will be fine just to run the emulator here. Except, I totally need to copy 3 characters now. Yeah, so this is our bottom line character, and then we have the solid ones. I actually think for the top line, I want to do a different character now that I think about it. And the reason why is I do want it the same as filled, but I actually want the very top line to not be filled so that it doesn't collide with the row above it. So I think that'll make some sense. So for this, we have 4 characters. I'm actually going to bring out this test pattern again. And we're going to do and03. And that'll give us some kind of checkerboard pattern that will display all the different kinds of characters. So we have the blank character, we have the fill character, just looking at left to right here. We have the blank one, the fill one, the line low, and the line high, and that'll be, I think, perfect for our little graph here. So great, this is going swimmingly. So we're going to clear the BG map data. I think we're going to want to do this like every frame eventually, but I think this will be fine for now. And actually, what I want to do here is kind of simulate what a graph might look like here. So we're going to clear the map here. And then, simulate the timing diagram line. And for this, I'm just going to do one line here. In fact, we'll just do this. And for this, we'll do something like that. So it'll just be every other one. In fact, let's shift that right as well. So it'll be, all right, let's even do divided by 3, because why not? And then, no, we'll do shift right 2, just in case that's slow as hell. And then for this, we just need 384 over 8. Gonna be 48 of these to fill the screen. So we'll just do one line to test. Hey, middle voids. No worries. Y undeclared? It sure is. And then we should get something like this. That'll be our little timing diagram. Although that did not work. Just in case. Let's see if this is something like that. X shifts right 2 and 1 plus 2. I think makes sense. Oh, wait. Did I do plus 2? Because I think that's wrong. Gotta delete this build folder again. No, we did want +2 there. This will just give us kind of a slowly alternating line here. There we go. So this is kind of what I imagined our timing diagram to look like. At the highest resolution, it'll be basically this. So particularly what I want to do here is, yeah, have like one of these character rows for a bunch of different bits. In fact, what I'm going to do here is simulate 2 of these. Just because I want to test this. I want to do like as much of this in isolation as we possibly can before moving on to displaying actual data. I think this is pretty fun. We'll do like 3 lines. And let's do, we have the map pointer here. Yeah, trying to avoid multiplications while doing all the address calculations here, because it should be fine as running totals. I expected one more row here though. What did I do wrong? I don't know what I did wrong. Oh yeah, 64 by 2 actually. That should be constant folded. There we go. That makes sense. Yeah, so this is also, we can just for the fun of it do that. Then we'll get alternating ones. Neat. So this is basically exactly what I wanted to get out of our timing diagrams. So literally I'm just going to have it be one of these rows for all the 16 bits. In fact, I can even do 16 of these because why not? Let's say we're looking at a 16-bit register. Then this is what our output's going to be. Pretty straightforward, and I think our little 20 megahertz CPU should be able to do this pretty nicely. I hope. we'll see. But yeah, so now I'm going to test this on the machine as well. So I'm going to test it on our emulator because that's pretty fun. Whoops. Can't find the file specified. Oh, we need a padded one. I guess this will do the padding for us. See you, Pelicus. Ugh. I have no idea why MSys does this crap, but it's so annoying. But yeah, looks just like we expect in Rush Boy. We'll test on the hardware as well. I've tried Commander. Commander, the biggest problem I have with that is that it's slow as hell. Like really bad. And especially at work, that is a huge literal time sink with how big our logs are and the kind of build processes that we have there. So I don't use Commander. Also, I don't know if it's been updated for MSys 2. I mean, I really should be blaming min_tty, I guess. Min_t. Some Finnish word. I should make like a build song. I'm not going to sing it, but that I can just like play whenever I'm building stuff. It can like watch my process list for Rust C and GCC and just play some dumb song when I'm building. Yeah, Konami I haven't tried. It's really only a problem when I'm like resizing the console a lot, which I'm not doing that much if I'm not on the stream actually. But yeah, it can be pretty annoying. Baggers, play something from Chrono Trigger. It doesn't fit dumb criteria though. No, that would be way too good. Man, I love Chrono Trigger. Perfect. Yeah, this is looking great. Rap or beatbox or something while building. Dark second, hook it up with MIDI. It would only take me a couple hours, as we discovered on Sunday. I'm going to be right back and use the restroom, actually. And I'm back. Sorry to whoever followed me while I was in the bathroom. I heard the notification noise, but I didn't see who it was. But thank you. Much appreciated. Yeah, where were we? Perfect. Yeah, so we just had this running. So I think this is going to be a really good viewer. So now what I'm thinking is that we'll need to start actually recording stuff. I'm not really sure how I want to do that. Thanks, Mad Moose. That's helpful. Yeah, skeleton. Still no sub button. I think... So we already have it set up so it's going to do... like drawing every other frame. And I need to check the interrupt pending for the game frame being set. And that's how we're going to... Yeah, so I actually had this written down in pseudocode. So frame select to 2. Actually, this needs to be at 1. Because if it needs to be every other frame, this actually has a bias to 1. So if it's at 0, it's going to draw every frame. If it's at 1, it's going to draw every other frame. If it's a 2, it's going to draw every third frame, for example. So I've already done that here. And then, oops, don't think we really need that anymore. Yeah, and then we need to loop for each game frame. So I need to observe the start of frame. Yeah, right. The first thing I need to do is wait for the first game frame. And then, yeah, we're going to observe, then we're going to enter this loop where we need to observe the start of a display frame. Write back FF to the interrupt pending register, which is going to clear all of the interrupts that are pending, and start recording. I think we actually need to record this as well, because I want to catch the display frame thing there as well. Yeah, and then here, I want to have like a tick counter. It's going to start at 0. So I'm thinking there's a couple different parts here because we need to do capturing and rendering. And the capturing is actually going to happen while it's rendering the screen from the previous frames capture, or the previous game frames capture, I think. I think this is interleaved in the way that this should actually make sense. So yeah, so here we're going to start recording stuff. Yeah, grab the interrupt pending reg and then reset the tick counter. So we're going to loop, grabbing the interrupt pending reg each iteration here. I think actually this too needs to be here. And I think at the very end of this too, or what am I thinking here? So we actually kind of have to observe these, because I think they're both going to have it at the same time. They may not, but I think they will. And here we just start recording. And I'm not sure if I want to try and include these or not. Don't think we'll need to. But yeah, so this will reset the interrupt pending register, and then we can start recording, where we just have this tick counter that starts at 0. And then we're going to loop, and we're just going to grab the interrupt pending register each iteration. If the register has changed, we need to make sort of a change list. And then we're going to, in that change list, we need a tick count and then the new value. So I think it's going to be like 6 bytes each. And then, yeah, we need to store that and then increment the tick counter. Yeah. And then we're going to do that until here. Something like that. And yeah, then we're going to clear it again, which I don't think we actually have to do. Then we're going to end the recording here. Grab tick counter for total ticks per frame, and then we need to render. Yeah, and here I didn't even wrote that I wanted to quantize that, which makes sense, I think. So we may end up doing, would it be, there were 48 characters for the full width, so 48 by 16 bits. Going to be 768 plots that we have to do. Well, technically we shouldn't have to do that many. Yeah. But we'll see. I'm thinking like max we need to do this many sort of float to int conversions and stuff every frame. That might be pretty shit. But we'll see. I mean, the worst that'll happen is we get glitches or something, so I can start with just one of these. But yeah, I think I've stalled enough here. So yeah, so we need to observe these first. So I think we're going to reset this first. Yeah, we need to... We only really... Actually, we don't need to enable any of the interrupts because they're still going to fire. So the first thing we need to do is... Yeah. This will be our main loop. Like that. I think I do that here as well. Or maybe I don't. Okay. But yeah, that should be our thing. In fact, I think... these are the VIP regs here. VIP.h. I kind of want to have that open, to be honest. Nice. So these are our different bits for the different things we're looking for. Really, there's not that many, actually. There's only 8 of these. Which is pretty rad, actually. Because then we don't need to do... We could do a lot less plotting there. So I think, actually... Let's do that. Let's plan on only doing 8 of these. Could have like a table of masks as well to see if they're 0 or not. But yeah. Or was it interrupt clear that we have to write here? This I actually want to check. So here we have the interrupt pending or interrupt enable, which is fine. And then, okay, yeah, so you don't write to the interrupt pending register. You write to the interrupt clear here. Okay, that's fine. Then I had this wrong and we do in clear here instead. No worries. So we'll do that. And I think I want to do that initially, and then I also want to do that as part of our capture here. So I think all we do here, there's a thing up here, basically this. So the interrupt pending stuff will just be set to 1 and it'll stay, the bits will stay 1 until we've actually cleared them explicitly via the clear register. So here, I'm going to do this. We need the frame start and game start. So I'm going to go ahead and OR these together. So what this should do then, yeah, just wait for those, which should be awesome. I think this will work out really well, you guys. Go ahead and start that. Then we'll go ahead and clear these again. We'll pseudocode here. And then we need to do our recording stuff here. Start capture. Now I think I was going to do like a set recording state. We don't actually need a recording state, I think, because the loop will just have this sort of implicitly. So we do need to reset the tick counter though. So do something like, I think int is going to be 32. Let me see if there's a types here that'll give us this. Nice. So if we do U32, for example, that'll be what we want, I think. Oh, there's also word and half word. I actually would like to use these for this system. It's not like we're writing portable code here. And then I kind of like to use the terms that are used in the emulator and in all the documentation. So we'll do word, capture total ticks. Actually, I'll do it like this. We'll do like that, actually. And then let's do it this way so we actually get the next frame at the end of this. Do the same kind of pattern here. This, by the way, is like exactly the same conditional that our emulator is breaking on, ironically. That's kind of funny. I think I'm really happy with how this is looking already. Yeah, then we need to grab the interrupt pending register each iteration here, so we can just do it again. That doesn't really matter. Or actually, let's not do that. I think is it half word that I had for the types here? Yeah. Or we'll do this. That's kind of nice, actually. And then, whoops, wrong place there. These get all small. Something's weird with my fonts here. I think I actually know what that is now that I think about it. We do the default style and the global one here. Let's see if that helps. And it didn't, so I'm actually going to put that back. Whatever. We'll worry about this list in a sec, I think. We'll increase the tick counter at least. Increase our tick counter. Repeat until we observe start a frame again. Then we're going to grab the tick counter for total ticks per frame. Not too bad. And then we want to actually render. So I think I'm going to do something like this here. So that we have this sort of starting value as we go into the loop, which may or may not be interesting. Not sure. Or actually, that'll be clobbered by this, won't it? No, it won't, because we'll do this. Previous register value. Like that. And then for every change, we'll go ahead and append an item to our list. So we actually also want to append the first value here. We definitely want to do that. So I'm not really sure how that's going to look yet. But I think other than the plotting, we're basically good to go. Now I think how I want to do this is, do we have malloc? We probably do. Because I want to play nicely with whatever the C compiler is doing with our memory here. So it'd be really nice if we had something like malloc, and I think we should in this little system. We may not, though. I mean, a global array with this stuff would also be fine. If we can do that. I've said numerous times, but I really do like this library here, because it is just so minimal. Yeah, we should actually just be able to do this as a big right here. Yeah, exactly, Daniel Collin. That's what I'm thinking. Or what I'm thinking now, at least. I agree now. Also, I am actually going to at least comment this out. Kind of get it out of the way here. Yeah. I just got to remember how to do this. We could do it like this, actually, and do a struct for this, which would be kind of nice. So let's just say we assume there would be 1,000 of these max. It should be like 8K. I think we have 64K in memory, so I think this would actually work. We're really not using the memory for anything else, so it wouldn't be that bad to use this. And I really don't think we'll get anywhere near 1,000 of these, but that should be nice enough. So do and here we'll do entry. So for this, we want a word timestamp, and then we want a hword value. Should be all we need. And then we should just be able to do static entries, max entries. That sounds correct. Just build this, see if I messed it up. Variably modified entries at file scope. What? Do I need static here, actually? Been a while since I used this language. I don't know why it's giving me variably modified. Okay, yeah, I can just do this as a define. It's just fine. So this is running. Okay, there we go. And now it's building. And then, yeah, so then we can just sort of linearly allocate in this, which is pretty cool. So we'll do this. Couple things here. We need a entry pointer. Yep. And then here we can do our initial value, which is going to be entry pointer is, I think this is how you create these structs in C. I don't remember. Need a refresher on this. I do like this. In fact, even easier, I can just do this. Or I'll just do entry even. So first we want to do this. And then we'll do entry dot, we had timestamp and value, right? And then we'll actually append it. So we'll do or why don't I just do this actually? I think this still would have been okay because this was an instance on the stack. But yeah, I'm just doing it through the entry pointer here instead, because then I can avoid the copy. That gets a little nicer. We can do reg value for that, and then we do entry pointer plus plus actually, which should give us the right size. So yeah, I think that's what we want to do here. And now just to test it builds. Won't do anything interesting. Whoops, wrong one. Nice. And then I don't mind just having this dumped here again, but of course we only want to do this when it's changed. So here's all we need to do here. If reg value is different than previous reg value, that's pretty cool. I think there was one more thing I wanted to do here when this happens. And that's to actually we'll do it here. Clear the new bits from the pending reg just so we can see things go back down again as well. So we'll do is reg value. So we'll just take the register and then we'll write out whatever bits were set here. And then because we've already grabbed the value, the rest should be okay. So I think this will do it, which is pretty rad. Nothing really interesting here will happen yet, but yeah. So we're going to capture until we get the next frame, and then we need to basically plot these. This is cool, you guys. And then we're going to plot. Now, first thing I want to do actually is just copy this plotting. And the reason I want to do that is because I want to be absolutely sure that this sort of alternating frame thing is actually happening and that this loop actually exits. So if we see this, the test graphics, that's a good sign. And we do, which is really cool. Gonna run that in Rustral Boy. Because that means it's actually stepping through the frames, which is pretty sick. Speaking of which, oh no, yeah, we already do this again in our main loop, so that's actually awesome. Very cool, actually. In fact, one thing I'm going to do here, we're going to do this. Or game frame index, just to be clear about that, because there's two different kinds of frames here. I actually want to do this to see that this looks like it's increasing the right kind of way. And let's do this. I just want to see that this is correct. Oh, we gotta delete our build folder again. It's so ridiculous. But I'm enjoying this. This is kind of fun. Perfect. So this is not actually capturing any data, but I just did this to see that it's actually updating every frame, which is so cool. This is actually going to work, you guys, I think. The plotting hopefully isn't terribly expensive, but this makes me happy to see. I'm going to test this on the hardware, by the way, before I move on. I'm actually pretty happy about this. I think I mentioned this last time I made one of these test ROMs that like I've thought about doing this low-level programming in C before. I've never actually done it. Like obviously I knew how it should work, but I'd done most of this stuff in assembler. So it's kind of funny to actually do this in C and just see how comfortable it can actually be. Yeah, exactly, Zamak. Beginnings of Virtual Boy demo right here. Of course, got to run this in Virtual Boy. Why does it not have the pad one already? Because it's being used by another process. Okay, so I guess this locks the file. I thought I couldn't find it again. But I may actually cut the stream off and continue this next week, to be honest. Because I just looked at the time and noticed that it was 9:30, and I actually have to get up a little early tomorrow. So I may just make sure this works, and then if it doesn't, I'll debug this until at least this works, and then I think I'll actually call it a day for today. But then next week we can do the rendering, which should be relatively straightforward, I hope. And then we'll have a pretty cool little tool here, won't we? So that'll be pretty nice, I think. I also just kind of want to see if this actually does work on the hardware as expected. Because like I said, many of these emulators might treat the timing a bit different for a lot of these conditions, so we may see some interesting stuff. But yeah, looking good in Virtual Boy. I did want to also test in this Reality Boy emulator as well, just to be sure. Looks the same. Looks a little choppier here though, which might actually be interesting. So let's see how it is on the hardware. It's actually silky smooth on the hardware, which is a really good sign. This is sick. This is totally going to work, you guys. Pretty happy about that. But anyway, this does work, and I think I'll call this quits for today, and we'll continue on this either next week, or I may end up, if I get the time, which I'm not making any promises, but if I get the time, I'll actually try to finish this program off stream, I think. Just because it's not much left and I could easily go over that code, and then we could sort of get on with actually debugging the thing. But anyway, thanks guys for hanging out. This was pretty fun. If I do a Virtual Boy demo, I should totally do this on stream as well, because this is kind of nice. Although then I'll probably set up a more proper development environment. But anyway, this works for now. Anyway. Thanks again for hanging out, guys, and I will see you next time.